Hi guys, welcome back to another Dawn Academy video. This time we're going for IB Chem. Okay, so today we're going to be talking about topic 20. It's an HL topic and we have some mechanisms that we have to memorize. So the ones that I'm going to be talking about today are going to be alkenes, benzene, SN1 and SN2. So alkenes, we have two. We have the HX and we have X squared. X2. We have benzene, we have nitrobenzene, and we have phenylamine, and we have SN1 and SN2. Okay, so to start off, we're going to have propene plus Cl2, which is chlorine. So we know that propene is C3H6, so we're just going to draw that out. We're going to say it looks like this. Here you have an H and an H. Only has one H. This has three H's. 1, 2, 3. Let's recount. Okay, 6 H's and 3 C's. Okay, and we're going to be adding some chlorine to it. We're going to draw out the chlorine like this because we want to see its bond. So what's going to happen here is that the electron-rich region of the propene is going to attack one of the chlorines. After this, the chlorine is going to become a little positively charged because the electrons from here, the electrons from this bond are going to go over here and they're going to repel the electrons of the chlorine. So the chlorine is going to become slightly positive. And when this becomes slightly positive, this is going to become slightly negative. And since it's going to be slightly negative, we're going to have some heterolytic fission and the electrons are going to escape from this bond into this chlorine. So what is going to happen to our structure here? Well, what's going to happen is that this bond is going to open. So there's going to have a bond here and we're going to have a bond here. A bond here. So a bond here and a bond here. But where is the chlorine going to go? Is it going to go here or is it going to go here? So that all depends on major and minor products, which we're going to talk about in this next reaction. But for now, because this is the same atom, it's not really going to make much of a difference in our product. But usually we're going to start with putting the slightly positive atom on the C with more H's, which is the C. We're going to talk about that a little bit more later. Okay, so we're going to open this little bond up here, this double bond. And we're going to, it's not a C, it's not an H, it's a Cl. So we're going to have a Cl here, we're going to have an H. Bond's going to open. And we're still going to have our H over here. But what's going to happen to this bond? We don't have anything to attach to it. So we're going to have a carbocation in the place of that extra unknown atom. And the rest of the molecule is going to stay the same. We're going to have C's and H's. But we're going to have a chlorine ion. Because remember, this chlorine over here took all our electrons. So now it's negatively charged. We're not done yet. Next, the negative charge is going to attack the positive charge. And hey, look, it's a perfect match. We're going to wind up with Cl, C, H, H, C. We're going to have our Cl here. H, C. And that is going to be our final product. Now, that wasn't too hard. But when we go over here, it's going to start getting a little more confusing. But it's still okay. So we have our double bond here, C, C, H. Okay, so this is what we have. This is our propene. And we're adding hydrochloric acid. So we're going to have our little bonds over there. And very similar to the last problem, what's going to happen? The electron-rich region is going to repel the electrons of this little H over here, which is going to make it slightly positive. Once it becomes slightly positive, this one is going to become slightly negative. And so then it's just going to take all the electrons. You know what? Take the electrons. Okay, that's how I think of it. It's like H and Cl are getting a divorce. So Cl gets the electrons. Okay, so here is when we start talking about inductive effect. So let's just take a look at this molecule. That's really zoomed in. So we're going to have our C here and our C here. So which C deserves the H? Well, we're going to look at the C with the more H's. Because Markovnikov says we're going to give the positively charged one to the C with the more H's, which is this one. This one only has one H. I mean, this C only has one H. So, theoretically, we would need to put our H here. But, occasionally, this C will take the H. So that's why we're going to have major and minor products here. So, which is why I'm going to put 2 arrows. But really, like, you would have to draw this, you'd have to draw this twice and put another arrow and get another product here. But I like to draw it with 2 arrows just because I am lazy like that. Okay, so what's going to happen here is that the double bond is going to open, same as here, but we have to mind where we're putting our H. So for the first one, we're going to have our major product, and this is because of the inductive effect. Let me just finish drawing this. Okay, so we have our H down here. Up here, we don't have anything, which is why we're going to have our carbocation. And here we're going to have the same H's and C's. Plus Cl minus, because we still haven't used that up. This is going to be our major product. Because we're giving the C to the H with more H's. It's also the H with more inductive effect. So this is a stable secondary carbocation. Whereas this one that we're going to see here is an unstable primary carbocation. That's horrible. So because it's horrible, it's going to be our minor product. Okay, plus Cl minus. So do you see here how this is secondary? We have inductive effect. We have a stable carbocation, whereas here we have a primary carbocation, barely any inductive effect, which is why it's going to be minor. That's the hard part. Got that out of the way. Now is the easy part. You're going to attack the plus, which is going to give I'm just going to copy this, which is going to give our final major product. Over here, we're going to remove this carbocation. We're going to put our Cl. Same is going to go for here. All right. All good. And our Cl is going to go here. Major and minor. Remember, inductive effect and stable carbocations. That's all we need to know. So, quick recap. Break the bond. Repel the C's. The positive one goes to the one with more H's. The negative one stays as a negative ion. The negative charge will attack the carbocation and produce the final product. This applies to both. Moving on, we have benzene. Okay, so first we're going to have to form, I think these are nitronium, something like that, ions. So how do we form that? Well, we take H2SO4, sulfuric acid, and we add it to HNO3. And I think it's a reversible reaction. Yes. We're going to produce water. We're going to produce nitronium. I still think that's called nitronium. Not quite sure though. Double check that. And we are going to produce HSO4 minus. So that's just the reaction that we have to know. And this is how we form NO2. We're going to need a balanced equation. So here's our balanced equation. And this leads us to the next part, which is forming nitrobenzene. So we're going to take our nitronium ions and we're going to add them to a little benzene. Oh, hello. Okay, so this is our benzene. And we know it has a little H here. Oh, no. Okay. So what's going to happen here is that the electron ring from this very saturated electron cloud is going to attack our electrophile, which is the nitronium ions. And that is going to lead us to a state of sort of transition state where we're going to have to, I'm enlarging this for the sake of the drawing, where we're going to have a dotted ring. Why is it dotted and it's open? Well, we are actually going to have a H and an NO2 both connected to the benzene ring at the same time with an overall positive charge. Note, make sure to leave this ring open and don't forget your positive charge. So after both of these things connect, the H is going to take its electrons and throw them back into the ring because it's leaving. So it's going to throw its electrons and then it's going to go. So now we're going to watch our little H leave. Okay. And now we're left with NO2 plus H plus. And that's it. That's how we make nitrobenzene. Yeah, that's basically it. So just a little recap. We formed our nitronium. If I'm saying this wrong, please let me know. We found our nitronium ions, and then the electron ring is going to attack this positive ion, and then it's going to take us into a transition state where you're going to have an open ring, a positive charge, and both of these connected at the same time. And then hydrogen's going to get mad and throw its electrons back in because the benzene doesn't want it anymore. Yes, it's a very dramatic story, so you can remember it. Remember, alkenes is divorce. This is a reaction to prepare you for hydrogen to throw its electrons back into the ring. And then NO2 takes the place and we produce a hydrogen ion, a hydrogen cation. Okay, now moving on to the third part of this possible reaction. So these can each be a question alone, but they might be a question together as well. So now we have to reduce nitrobenzene, which is this. Which is this. This is nitrobenzene. And we're going to reduce it into phenylamine. Phenylamine is simply a little benzene with NH2. First step to doing that is we're going to take our nitrobenzene and we're going to take it and we're going to put it in some tin and hydrochloric acid. And then we are going to produce some phenylammonium ions. Oh, sorry, that's kind of an ugly ring. But we're going to produce some phenylammonium. So we know that this is ammonia. And we're going to connect it to a phenyl, so it's called phenylammonium. And since it's positive, we want to reduce this positiveness. So in the next step, we're going to have our little phenylammonium. Oh no, that's horrible. We're going to have our phenylammonium, and we're going to add some hydroxide to it to take away some of the H's. And we are finally going to end up with our phenylamine. There we are. We're also going to get water as a byproduct. And there is our phenylamine. So, recap again. So we're going to start off with some tin and hydrochloric acid. And then we're going to get phenylammonium ions. But we don't want the ions. We don't want an extra H, which is why we're going to take that away with our hydroxide. And we're going to produce phenylamine and water as a result. Yeah, that's basically it for benzene. Okay, SN1. So some basics you should know about SN1 is that it only works for tertiary alcohols. No, tertiary halogenoes. You know, the alkanes. Where's SN2? Oh, here it is. SN2 is only going to work for primary halogenoes. Okay, tertiary and primary. That is basically what you need to know. And another note is that in SN2, we need to draw it in 3D. So we're going to need to draw this 3D things in time. So we're going to have this. We're going to have our H and our Cl. Over here, we can draw the structured versions. We're going to need to draw the structured versions, actually. Yeah. Okay. let's get started. So since it's tertiary halogenoes, alkanes, I'm just gonna draw us a little butane. It's gonna be a 2-chloromethyl. Oh, not a C. I want an H. I've gotten the hang of creating organic molecules for this sake. Okay, and what we're going to be adding is a nucleophile because it's called SN. N is for nucleophile, substitution nucleophilic reaction. So what is going to happen here? Oh no, sorry. In this step, we're actually not going to add that. I forgot that this is 2 steps. Kind of juxtaposing the one there. This is one step. Okay, so first what's gonna happen is that, story time, the Cl just can't take it anymore, so it's just gonna leave. Okay, bye. Now we're gonna wind up with this 1 2 3 4 5. Okay, just gonna draw it again. No, I'll copy paste it. Since the Cl is leaving, we'd have no choice but to replace it with a carbocation. So it's kind of also a divorce situation, but we're not divorcing the double bond, we're divorcing a single bond. And yeah, that's what we're gonna get. Next, and this is the slow step. Next, we're gonna take our carbocation, our carbocationed molecule, and we are going to add it to some hydroxide. What is going to happen now, you can probably imagine, the negative is going to attack the positive, and we're going to get, yes, I'm pasting again, and we are going to get an alcohol. Boom, that's SN1. Cl is going to, recap, Cl is going to divorce this chloromethyl. Yeah, I'm not gonna say that. This molecule, the chloro, is gonna divorce it, and it's gonna leave, and we're gonna get it here as a byproduct. Oops, my bad. And then we're gonna get a carbocation. After that, when we add our OH, the minus is gonna go and attack the carbocation, and it is gonna become an alcohol. Okay, now SN2. I'm going to do down here, zoom in a bit more. So SN2, we're going to have our little carbon. We're going to have it in 3D form because that's how you need to have it. So we're going to have our chloro. I'm just going to make it a methane. Chloromethane. So we're going to draw our OH over here this time. Why? Well, because we're going to have to attack the C from behind. It's a back attack. Can you believe that? OH is so sneaky. And because of that back attack, the chlorine is going to leave. It's going to get scared. It's going to be like, oh, okay, OH is attacking from the back. I'm going to leave. I'm going to go. Coward. Okay. Now we move into transition state. Because the OH is coming from the left-hand side, so why stereoisomerism is so important in this case, the Cl is leaving from the right-hand side, which means the OH is going to be connected from the left-hand side to the C. We're going to keep everything else the same. H, H, H. And we're also going to have the Cl on the left-hand side. And we have to remember that it has an overall negative charge. And then we are going to have our final product, which is going to be the OH connected to the C. And now the H's are going to flip because it's side-specific, stereo-specific, I mean. H, and we're going to add our Cl on the end. And this is a slow step. The first one is slow in this case. In both cases, actually. This is fast. Oh, I forgot to write fast here. Fast. Boom. Yeah, so that's SN2. Oh, okay, recap. So OH is going to back attack the C. So the Cl is a coward, so it's going to get scared and it's going to leave. but in the process, they're both in the same zone. So OH is trying to attack the C while Cl is trying to leave the C, and it's just a whole messy situation, whole negative situation. Now the OH is going to bind from the left-hand side. Also remember, it's area specific. So you're only going to bind here. You're not going to bind here. No, you can't bind there. You have to bind from the left-hand side. And everything else is going to remain the same, but these H's are going to be a little inverted. And we're going to have our chlorine ion. And yeah, thank you for keeping up with the IB HL Chem drama stories. Don't forget to make them a story so you remember them better. Bye.